Picture a perfectly sealed box. Now, you try to empty it out completely. You pump out every single atom of gas. You scrub out the dust. You block every photon of light. And let's say we use some sci-fi tech to suck out all the unseeable stuff too, like dark matter. You seal it up tight.
So what's actually left inside that box? Common sense screams that the answer is nothing. Just a perfect, silent, dead void. But the universe, well, it doesn't really care about our common sense. Quantum mechanics reveals a totally mind-bending truth. Not only is your perfectly empty box actually filled with immense energy, but all your hard work to empty it, it didn't even make a dent.
We call this zero-point energy. To understand why space can literally never be empty, we have to look at Heisenberg's uncertainty principle. It's kind of like trying to take a sharp photo of a speeding race car. You can't pin down exactly where it is and how fast it's moving at the exact same time. Because of this built-in fuzziness in reality, nothing can ever sit perfectly still, not even the fundamental fields that make up the universe. There's this unavoidable, constant jitter, meaning absolute nothingness is practically boiling with energy.
Testing the empty void. What exactly is empty space?
Now this created a huge problem for scientists. How do you physically prove that a vacuum is actually doing something? The old view, the classical vacuum, paints space as completely empty, silent, with zero energy. But the quantum vacuum? It's a completely different beast. It's a chaotic, boiling sea of temporary, virtual particles. These particles pop into existence, borrow a tiny sliver of energy from the vacuum, and then instantly destroy each other. It's literally the background static of reality.
The force of nothing, the Casimir effect. So how do we test this? We look at a beautifully simple experiment measured in 1997 by Stephen Lamoureux. Let's walk through it. He took two incredibly flat, completely uncharged metal plates and put them inside a perfect vacuum chamber. Then he brought them ridiculously close together. We're talking just nanometers apart. According to classical physics, with absolutely no electrical charge and practically no mass, these plates should just sit there doing nothing.
But the result was absolutely mind-blowing. The plates were pushed together. The vacuum itself exerted a physical force. How is that even possible? Well, think back to those virtual particles. The tiny gap between the plates only allowed certain very small wavelengths of particles to pop into existence. But the open space outside the plates, that had an infinite spectrum of particles bouncing around. Because there were more quantum jitters hammering the outside than the inside, it created an actual physical pressure out of literally nothing. The void isn't empty, it pushes.
Seething the entire universe.
Scaling up the quantum jitter.
We're going to take a massive leap now, from tiny subatomic plates right to the entire universe. During cosmic inflation, just a fraction of a second after the Big Bang, the universe expanded faster than light. As it did, those microscopic quantum jitters in the vacuum were stretched to cosmic proportions. Those stretched fluctuations created tiny differences in gravity, eventually clumping matter together to form stars, galaxies, and the vast cosmic web we see today. You and I exist because of a quantum jitter. And it works the other way too. Stephen Hawking realized that if a pair of these virtual particles pops up right on the edge of a black hole, one can fall in while the other escapes. Over trillions of years, this steals energy, causing the black hole to slowly evaporate into nothing. So this boiling void, it birthed our galaxies, and it will eventually kill black holes.
The Boltzmann brain paradox, an existential crisis. Taking this science to its logical extreme leads to a pretty wild existential thought experiment. See, over an infinite amount of time, a random quantum fluctuation could spontaneously form literally any structure. If you wait long enough in a completely dead, empty universe, those virtual particles will eventually arrange themselves into complex things purely by chance. Statistically speaking, it is infinitely more likely for the vacuum to accidentally burp out a fully formed, conscious human brain floating in space, complete with false memories of a life it never lived, than it is to create the incredibly complex, highly ordered universe we actually observe right now.
To put that scale into perspective, 10 to the power of 10 to the power of 50 years. That is roughly the absurd amount of time needed for a Boltzmann brain to just spontaneously fluctuate into existence from the vacuum. But in an infinite universe, even this impossible event would happen an infinite number of times. It creates a terrifying statistical paradox. By the math, you are far more likely to be a brief fluctuation in the void, hallucinating this exact explainer right now, rather than a real biological human being sitting in a room.
Okay, before you have a full-on existential crisis, let's look at what theoretical physicist Sean Carroll has to say. He calls these models cognitively unstable. Why? Because if you are just a random brain floating in a void, then all your memories, your logic, and your scientific observations are just random hallucinations, meaning you have absolutely no reason to trust the very laws of physics that led you to deduce these floating brains exist in the first place. Physicists use this paradox as a giant red flag. It exposes flaws in our current mathematical models. It's not a confirmed physical reality you need to stress over.
The greatest unsolved mystery, the cosmological constant problem.
And that brings us to the grand finale of our explainer, the biggest headache in modern science today. On one side, quantum field theory calculates that the zero-point energy boiling in the vacuum should be massive, like an infinite roaring ocean of energy. But when cosmologists actually look out at the universe to measure the expansion caused by this energy, the observed amount is incredibly tiny, barely a drop. The mismatch between what quantum physics predicts and what we actually see is 120 orders of magnitude. That is a 1 followed by 120 zeros. It's literally the worst theoretical prediction in the history of physics. Our two absolute best frameworks for understanding reality, quantum mechanics and general relativity, completely disagree on the fundamental nature of empty space.
So, we know the active void is real. We physically measured it, pushing microscopic metal plates together. We see its fingerprints written across the cosmic web. Yet, its energy completely breaks our greatest equations, and its statistical implications challenge our basic perception of reality. So I'll leave you with this final thought. If the empty space all around us is boiling with the power to create galaxies and destroy black holes, yet remains this profoundly misunderstood, do we truly understand what it means to exist?